Alright, we have another video, limits at infinity. We're looking at rationals, and this is our part 3 of looking at these. As you can see, I've got a very disgusting example, 2 examples that involve roots. Okay, so a couple important points that aren't obvious to most students, so I just want to let you know that when they give you a square root, they've already decided that the sign of the square root is positive, right? Because they didn't write a symbol out in front, we're going to assume it's positive. If they wanted us to consider the positive and the negative square root, they'd write plus and minus. If they wanted us to only consider the negative square root, they'd write a negative. So when I see just a root, I'm assuming that it is positive. Okay, so let's see what happens here when I go to try to solve one of these problems. Okay, as we know, when I'm looking at limits as we go to infinity, and I look at a fraction, I want to know, is one dominating the other, or are they keeping pace? Okay, so what I'm going to do is I'm going to look at the leading coefficients of the top and the bottom. So the leading coefficients are going to look like that, which is the square root of x to the 6th over x cubed. That's what that's going to act like. Okay, now, the square root of x to the 6th, the square root of x to the 6th is x cubed. So right now, it appears that this is just going to act like 1. So I'm like, whoa, wait, did I just screw that up, or is it really going to act like 1? Well, let's see a second. As x goes to infinity, right, this is positive infinity, a positive number. When I take this positive number and take it to the 6th power, it's still positive. When I take the square root, it is still positive. So this x cubed is a positive number. And down here, this x cubed is going to be that same positive number. So yes, a positive x cubed divided by positive x cubed is 1. So if we were to graph this original function in Desmos and walk on it forever to the right, what we'd see is we'd have a horizontal asymptote at y equals 1 as I'm going to positive infinity. Okay. Seems kind of weird, but true. Okay. Now I want to point out, though, that something weird is going to happen down here with negative infinity. Okay, we're going to start off our investigation the same way, that we're going to circle the degrees of the top and the bottom. Okay, and again, it appears like it's x cubed over x cubed. However, I'm going to negative infinity, so let's talk about what happens when I go to negative infinity. So a negative huge number. When I take a negative number to an even power, that whole thing's going to be positive. So this top's going to be a positive number. When I take the square root of that positive number, it's still going to be positive. Okay? So I'm saying a negative number to the 6th power is positive. The square root of a positive is positive. Okay, now, a negative number to the 3rd power. Negative number to the 3rd power is a negative number. So what's happening here is the top is going to be positive, but the bottom is going to be negative. Okay? Because take a number like negative 5. Negative 5 cubed, negative. So a negative a million cubed, negative. But a negative a million to the 6th is positive, so the top's positive, the bottom's negative. Okay? All right. What's a positive divided by a negative? Negative. So what's going on, and again, you could check this using Desmos, is that we are going to have a horizontal asymptote of negative 1 as we go to the left. So what's happening is on the right, our function is being attracted to this guy. On the left side, it's being attracted to this guy. So it's doing some weird stuff in between, but it's going to be attracted to one side and then attracted to the other. Okay. There are a couple of problems in your homework, maybe 2 or 3, that use this idea. You'll see in my solutions, I write pluses and minuses so you can note what it is that I'm doing. So again, you can always reference this video, watch it as many times as you need to make sure that you're getting the idea of what happens with roots when we're talking about positive infinity and negative infinity.